Hi everyone, hope you are doing great today. Today I'm going to start a new chapter which is basic chapter in statistical methods. This is the introductory part, the nature of statistics. First, we'll see what is the statistics. Actually, in day-to-day life, we are using these statistical methods a lot, but we don't recognize whether this is statistics, mathematics, or whatever. So let's see few examples what we are doing in statistic and how we are dealing with day-to-day life problems by using statistics. Okay, let's consider example 1. In TTU, 75% like football, 20% like baseball, 5% like soccer. So in this example, you can see that they have summarized the results. One particular results they have summarized and interpreted. How they interpret it? Using numerical method, simply by using a percentage. So when you read this, you can see that 75 from TTU students they like football, 20% student in TTU they like baseball, and 5% in TTU students they like soccer. So this is a one way to show or explain summary of a result by using statistics in a statistical way. Okay, let's check the second example. In US and Canada, nearly 30% of deaths each year due to heart diseases. So, death occurrence due to heart diseases, they have mentioned 30% in US and Canada. So, when you read this, you can identify, okay, you in US and Canadian population, they uh, die each year due to heart diseases about 30%. So this is the way how we summarize our results or explain our results. There are a couple of examples, you can read it. Okay, let's move to few definitions. Major thing, statistics. What is this statistics mean? It is not just a word, it explains few things. Actually, there is no formal definition for statistics. If someone asks what is statistics, there is no formal definition, but it is some kind of definitions. It's collection of few definitions. So I picked two definitions. Statistics mean a fact or data, can be numerical or non-numerical, organized and summarized, so we can provide useful and accessible information about the particular subject. That is we call statistics. In another way, we can say that statistics is a science of organizing and summarizing numerical or non-numerical information. Remember that we are dealing with numerical or non-numerical information. So in statistics, we are dealing with this numerical or non-numerical data, organizing and summarizing, finally interpreting them. So this is the way how we dealing with statistics. Next definition, you should know population and sample. These are two giant terms in statistics. So let's see what is population. Population is a collection of all individuals or all items under consideration in statistical study. So if we consider population, which means it includes all the elements in our study area. For an example, we can see I'm going to study the TTU, the like this. The first example, example 1, I need to like the students how what they like, which sport they are like, or which sports they are like, something like that. So I consider all students in TTU, that we call population. All the students in TTU we call population. Okay, next thing is sample. Sample mean a part of the particular population. In this sample we consider a portion from our population, which mean, for an example, graduate students in TTU. I'm going to consider graduate students from TTU students. So TTU students, which includes undergraduate and graduate students. From that population, I'm going to select graduate students only. So it is a like subset from the population. So simply, sample is a subset of population. In this picture, I think you can easily understand what is a population and sample. Population consists almost all, which means, let's say, all elements in our considered studying area. We are taking some of them as our sample. So there is one thing you should clearly understand. If you consider this sample, whatever inside this sample, which means all the items or all the individuals in this sample, they have exactly same characteristics as they have in the population, because you are selecting this sample from your population. So each element in the sample, they have their original characteristics. They cannot that cannot be changed. Okay, now let's see major types of statistics what we are dealing with. There are two major types of statistics we call descriptive statistic and inferential statistics. First, we will look at what is this descriptive statistics. This means this consists of methods for organizing and summarizing information. These methods are like construction of graphs, charts, tables, or some other calculations in descriptive measures. For an example, a study asked 100 students in TTU which game they most like. So they have mentioned few games: football, baseball, soccer, and they have mentioned the percentages as well for each of these games. This is we call descriptive statistic. Here we have organized according to the games, summarized the information. So when you see this, you know how many students are like dealing with football, or how many students like football, how many students like baseball, something like that. So it is easily you can recognize what is going on here. This is some kind of numerical representation. uh, Descriptive study may be performed either on sample or population. This is something very important. This descriptive statistic you can use for sample or population. This is how it works. If you use sample and do your calculations, show your graphs, interpret about the sample, it includes into this category, descriptive statistic. If you use population, do your analysis, do your calculations, draw charts and everything, but you interpret about that population, that also includes to this descriptive statistic. So you are talking about sample, doing whatever within that sample, it includes this descriptive statistic. If you are dealing with population, then you are uh, doing your calculations about this population and interpret about the population, it also includes this descriptive statistic category. The other one is inferential statistics. This is totally different from descriptive statistics. Inferential statistics mean it consists of methods for drawing and measuring the reliability of conclusions about population which based on your sample calculations. So when you calculate or when you do your calculations, drawing graphs, whatever, using your sample, and at the end you draw a conclusion about population which includes to this inferential statistics category. So please keep this in your mind. You are dealing with sample, but you are drawing conclusion about population belongs to inferential statistics. Okay, uh, that's the thing what I have mentioned in this blue color text. If the information is obtained from a sample of a population and the purpose of the study is to use that information to draw conclusions about the population, then the study is inferential statistics. Okay, next I'm going to explain two specific terms in statistics. Parameter. Parameter mean numerical summary of the population, which mean some kind of letter or some kind of variable which we are using to denote a population characteristics. For an example, I have actually you will see this example in future lessons. I have normal distribution with mean mu and standard deviation sigma. So this mu and sigma, those are Greek letters, we call they are parameters. Next one is estimate. For this estimate we use another word, statistics. This statistics is not same as the statistics idea what we have discussed before. So statistics or estimate, which mean numerical summary of the sample taken from the population. So estimate mean it is a numerical summary of the sample which we have taken from the population. So always we take a sample from the population. Why we are dealing with this kind of sample without dealing with the population directly? Because if you are dealing with population, you saw that the size of the population is bigger than, it's much more bigger than sample size. So if you are dealing with TTU students, all the TTU students, it can be like 45,000, maybe roughly 50,000. But if you are taking a portion of that, if you are taking a subset of that, it can be like 1,000. So it reduces the cost, it reduces the time as well, and it is really easy to deal with rather than a population. That's why we are using sample instead of population. But there is no restriction. If you want, if you decide I need to deal with population, then you can go ahead and do with that. In this course, in the problems, especially they have mentioned what you are dealing with. You are dealing with population or you are dealing with sample. According to this population and sample, your calculations, they can be changed. We will discuss that, this kind of more information later. There are a few exercises. Let's see this exercise number 1. It has mentioned that an employee at the local ice cream parlor asked 3 customers if they like chocolate ice cream. So identify the sample and population. When you read the question, you should clearly identify what is the sample and what is the population. So in this case, it is easy to identify what is the sample. Sample means the portion from the population. So what is the sample? Sample is what we are going to test. So in this case, that seller is asking from 3 customers. Asking from 3 customers. So definitely sample size is 3. Now, how do we find the population? It is a little bit tricky, but if you read this statement clearly, you should be able to identify this. Uh, in this case, they have mentioned if they like chocolate ice cream. So who like chocolate? Who like chocolate ice creams? That's the problem. So if you think we need to consider only people who like chocolate ice creams, no, that's not the case. He is going to do this. He is going to perform this test for his customers. So customers are the population. From that customers, he need to identify who like to uh, uh, chocolate ice cream, who like to strawberry ice cream, something like that. So in this case, population is the customers, all the customers. I think answer is D. Yes, sample is 3 selected customers. Population is all customers. Among all customers, he need to figure it out who like chocolate ice cream. So he selected 3 customers. That's how it works. Next one. In statistical abstract of the US, average professional athletes' salary in baseball, basketball, and football were complied and compared for year 1995 and 2005. Okay, we need to identify whether this is a descriptive statistic or inferential statistics. You can see that everything is summarized, and this first column is sports, the other column is average salary for 2 years 1995 and 2005. What are they talking about here? Average professional athletes, salaries of average professional at average salary of professional athletes. Okay, so what is the definition of descriptive and inferential statistics? If we are talking about sample, do our calculations and summarize the results about sample, it is descriptive analysis. If we are talking about population, we are doing our calculations, drawing graph, everything about the population and interpret about the population, it is also a descriptive statistic. But if we are dealing with sample and at the end we draw the conclusion about population, it goes under inferential statistics. So what about this case? Average professionals in US. So they are talking about all the professional athletes in US. So this going to be a population. So they are talking about population, and they have summarized their results about this population. You can see here, complied and compared for the years 1995. These are the average salary. So they talk about population, and they have mentioned their summary under their population. So start from the population, end from the population. This is a descriptive statistic. Okay. Exercise number 3, a little bit tricky one. Researcher randomly select a sample of 100 students, okay, from the students enrolled at the particular college. She asks each student his age and calculates the mean age of 100 students. It is 21.3 years. Based on this sample, she then estimates the mean age of all students enrolled in the college to be 21.3. Okay, this example is very clear. A researcher randomly select a sample from 100 students. So in what way are descriptive statistics involved in this way? It is easy. She has selected sample of 100 students who have enrolled at particular college. From them, she has taken their mean age is 21.3 years. That's how we deal with descriptive statistics. Okay, then next question: in what way are inferential study involved? Inferential studies are involving from here to here. Based on this sample, she then estimates the mean age of all students enrolled at the college, 21.3, college to be 21.3 years. So based on sample she has drawn a conclusion about population, all the students. So this gonna be under inferential statistics. So that's how it works. I think this example give you a better idea about what is descriptive statistics and inferential statistics. Okay, uh, the next one is how we perform this kind of experiments or studies. How we are doing this. For that, answer is there are two specific statistical studies we call observational study and design of experiment. Under observational study, it is researchers simply observe the characteristic or behaviors and take the measurements. It's something like a survey. In this case, observation. In this case, observations. Observing data is observing existing data. So data is there. We are observing that data and make our conclusion or do our calculation, whatever. But in the design experiment, researcher impose treatment and control and then observe the characteristic and measurements. So the researcher has the full authority to impose their rules and regulation before they start their experiment. This kind of experiment most of the time you can see in drug experiments, how they test a drug, something like that. So in statistics we are doing these two kind of statistical studies. In this example, I'm going to explain you using these two exercises. Actually, this is some kind of example. I'm going to explain you how we deal with this observational study and design of experiments. Okay, first exercise: an educational researcher uses school records to determine that in one school district 84% children live in two parent homes graduate high school, while 75% of children living in single parent homes graduate high school. So this belongs to which one? Design of experiment or observational study? See, educational researcher used school records. He is using existing details or existing information. So this directly go under observational study. So answer is observational study. Next one. A clinic give a drug to a group of 10 patients and a placebo to another group of 10 patients to find out if the drug has an effect on the patient's illness. Okay, clinical trials almost all goes under design of experiment, but in this case as well you can see they give a drug to a group of 10 patients and a placebo to another group. So this is definitely design of experiment. Researcher design or researcher impose his rules before the experiment and then do the experiment and take the measurements. So answer is design of experiment or design experiment. Okay. The other thing is how we select these samples. You saw that we take a sample from a population, but you don't know how we select this sample. There are many techniques to select a sample in statistics. This is the very easiest and simplest sampling technique what we are using in statistics. We call this simple random sampling, or we call random sampling. We use both. In shorthand word, we use SRS. We use this method to take samples from the population. So census mean obtain information on entire population. Sampling mean obtain information from subset of a population, from a population. It's a subset of a population. It should reflect all the characteristic of the population. So remember that. For this case, this random sampling, we use probability sampling, because we should have a method to process this sampling technique. So probability sampling mean we use a random device. Random device mean either tossing a coin, using a random number table, using a random number generator, using something like that. We can select our sample under probability sampling. In these days, actually in present, we don't use random number table. We just used random number generator because we have mobile phones, we have laptops, so simply we can generate a random number and take our decision. Next thing is what is actually this random sampling? It is a sampling procedure, as I mentioned before, which each possible sample of given size is likely to be the one obtained, which means all the individuals or elements in the population, they have an equal chance to go into the sample. Okay, it's a fair game. Okay. Next one is this simple random sampling. We can divide into two cases, like with replacement, without replacement, but we are not going to discuss in detail here. With replacement mean we replace what we have taken before. Without replacement mean we do not replace that item or individual which we have taken before. Is it simply that one? If I for an example, I'll tell you something like this. I have a box with blue color balls. There are 10 blue color balls. Okay, I'm going to take a one ball randomly, like blindfolded. I'm taking a ball and put into another box. Okay, now in my original box I have 9 balls, right? Because I have taken one blue color ball. Next run or next iteration, I have 9 balls in my box. I'm taking another ball and put it into another box. Now I have 8 balls in my original box, right? So likewise, step by step, the number of balls are decreasing. This kind of method we call without replacement. Okay, the number of individuals in the population, it's decreasing. The next case is, okay, I have 10 blue color balls in my box. I'm taking a one ball randomly. I pick a one ball randomly. in next run or next iteration, before I select another ball, I put back that blue color ball I have taken before. So now before the test I have 10 balls again. So each run I put back my blue color ball to the original container. So this called with replacement. So number of entities or number of individuals does not decrease, it remains same. Okay, there is a quick example. Actually it's a exercise. Okay, in the finalists in an essay competition are Lisa, Melina, Ben and Eric. Consider these finalists to be population of interest. Okay, list the possible samples without replacement, and order doesn't matter. Remember that order doesn't matter. What is the order? Okay, if we consider L and M, LM. If order doesn't matter, LM same as ML. Okay, if you switch those two, it doesn't matter. Of size 2 can be obtained from this population of 4 finalists. Okay, size 2. So we have to deal with pairs. We have to identify what are the all possible outcomes from these 4 candidates. Okay, pairwise you have to identify how many pairs do we have in this case. Okay, for that one I'll show you this L, Lisa, M, I don't remember, Melina, B, Ben, E, Eric. So first pair is LM, next one is LB, third one is LE. Okay, so now we have done with Lisa or L. Next I can cache Melina, M, MB, ME. Okay, MB, ME. See this one, MB and ME. Then next I have Ben with Eric only. Since we are not considering order, either ME or EM are same. Okay, so altogether we have different 6 pairs. So total we have 6 pairs. Okay. Okay. Describe the method for obtaining a simple random sample of 2 finalists from this population. Okay, how we do this? If you need to pick 2 of them, what you have to do? Write their names in a piece of paper, put it into a box or whatever you cannot see, and shake it. You have to mix them up. Then blindfolded, pick 2 slips of paper. Now you can, okay, you have selected 2 people randomly. Okay, that's how it works. That's actually how we're dealing with this kind of sampling. So the last part of this question is, if a sample random sampling method is sampling method is used to obtain a sample of 2 of the finalists, what are the chance of selecting Lisa and Ben? What is the chance to select Lisa and Ben? L and B, they are together, they should be together here. So how they are together here? LB, see, LB, we have one pair. We have one pair out of how many? Out of 6 pairs, including that pair. Okay, LB, because they asked Lisa and Ben, which means LB out of 6, which means that chance is 1/6. Okay. Okay. The last question here I need to explain you. A researcher is conducting a telephone poll. She has listed 581 registered voters, okay, and need to interview them, interview 12 of them. Okay, you have 581 name list, but you need to pick only 12. How do you pick that? In the past we used something like table, we call it random number table, but I'm not going to talk about that random number table in this video, because we are not using that random number table now. We just generate a random number and do our work. But I'll show you what is this random number table. It is something like this. It's just a table. First column mention a line number, the other columns mention the digits category. Normally each number has 5 digits, and you can select if you want first three digits or last 3 digits, something like that. You can move either row wise or either column wise. That's the beauty of this table. But you don't need to know about more in this table. We don't use that nowadays. Anyway, uh, if you want more about this random number table, you can just read the notes. Okay, I think I have explained everything very clearly. We'll see what I have discussed. I have explained you what is the statistics, what is the definition of the statistic, what is the population and sample, most important terms in the statistics. What are the major types of statistics, which are descriptive statistics and inferential statistics. And then I discussed the most important classification of statistical studies, which are observational study and design of experiment. Next, how we select the sample from the population. Easiest way is to use simple random sampling. Then I give you an idea about with replacement and without replacement. So I think I have covered the very basic steps or very basic stuff in statistics. So I hope that you have enjoyed this video. So thank you very much and see you soon.